Hello, my name is Jacob Alvarez-Rucoba. This is my IAP presentation for CAN number 1. So a little background about this experiment. Every person in the class was given a can containing random contaminants. I was chose CAN 1, and each we were also given a list of possible contaminants, organic and manufactured ones. The list of the possible contaminants are on the right there. You can see the potential manufactured ones going down. Then you have the possible volatile organics. Now, originally they were given just the names, but we had to look up certain physical properties of these chemicals to look up how we would test them later on. So I received the molecular weight. I looked up the molecular weight and boiling point of each of these chemicals. Next, we had to create a scenario and a location that we would be conducting this research on, trying to determine an issue. And then we had to create a plan of how we're going to detect these once we received them. So my situation that I thought of was a situation close to where I live, the Coachella Fest, which is a popular music and arts festival held in Indio, California. People across the country had come to attend the festival. That's how popular it is. And the issue was that at the end of the event, there was cases of unidentified illnesses, and couldn't determine what it was, so they had to check the soil samples to be sure. And these soil samples, because there was a lot of people there, was collected in more popular areas because that's where it thought to be there would definitely be some sample there. The ultimate conclusion that we're trying to get to is to determine the cause of illness from the soil samples. So let's talk about the location itself. Coachella Fest is held at the Empire Polo Club in Indio, California. I have put the coordinates and also achieved two geographical maps of the surrounding area. The surrounding borders of Coachella Fest. To the north is an elementary school, which is kind of cool. To the west, we have a country club because Indio has a lot of country clubs and a lot of golf courses. To the south, we have Desert Equestrian Veterinary Hospital, so the horse hospital. And to the east, you have ranch land because there's another thing in Coachella Valley, which is where it's held at. There's a lot of ranch land there. So, like I was talking about earlier, the most popular area that we took the soil samples from was from the main stage because that was the most abundant of people were there. So my analysis plan was to perform two different. We broke it down to both the volatile organic components and the manufactured components. So to detect the volatile organic components, I would use gas chromatography mass spectrometry, or GCMS. The reason why we chose this is because it performed on smaller, more volatile samples. As stated in the title, they are volatile organic components. It's more challenging to ionize and separate using liquid chromatography, so GCMS would be a lot better than using liquid chromatography. Headspace, that's why you're not using the HPLC for the volatile organics. We would also be using headspace sampling to detect these volatile samples because some of the samples on that list would vaporize very fast and would be able to be detected if just inserted into the machine, as well as it can ruin any other detections later on. And at the end, we would like to compare the results to known chromatograms to determine what truly is in this soil sample. For the manufactured components, we would separate through the column, and then the good thing with this is particle sizes from 1.7 to 5 micrometers, but could also range up to 10 micrometers. And another thing, if you notice on our list, there was a lot of pharmaceutical ingredients, and HPLC works predominantly well with pharmaceutical ingredients. And these images on the right, these are just example of the instruments. I don't have the actual photos of the instruments we used, so I just got some images of usually what the machines would look like. So let's talk about the procedure for GCMS. first what we did, we added the dirt to we used crimp headspace glass bottles. As you can see on the right, there are 20 mils of those. We added the dirt, a sample of the dirt to those bottles. Then we weighed that dirt out to 0.911 grams. Then we added canola oil to the dirt, which was 1.58 grams. The reason why we added the oil, because we had to have something to go off of to compare it to, because if you just try going off the sample, the machine doesn't have anything to compare it to but the sample, so you're just not going to get a good reading. Next, we ran through the GCMS instrument after it collects the vapor in the headspace, because it doesn't actually touch the liquid itself, or else again it would contaminate the machine. It runs the volatile samples through the glass chromatographer, which then detects the fragmentation pattern of detected samples. So we actually detected 3 different samples, different results here, and I'll go left to right. So sample A is the peak that was detected on the chromatogram, and below sample A is an enhanced version to show the different peaks, and B of that one is the known chromatogram for what is most similar to. So the first one was most similar to dichloromethane. So picture A1, that's this one on the left, is the enhanced version showing the different properties of the peak. Image B is a close match to A1, which is dichloromethane. The isotopic peak of chlorine was found at MZ value of 49, 51, 84, and 86. 86 and 51 peaks represent one chlorine atom with 37 atomic mass units. 84 and 49 peaks represent the carbon which atomic number 12, the loss of the chlorine radius at 35 from the molecule, the CH2Cl2, which is 84, making the CH2Cl+, which is a 49. The loss of the chlorine isotope, which makes 37 from the dichloromethane. The next one in the middle, we have image A of the second peak of the chromatogram is the enhanced version showing the different properties of the peak. Image B is a close match of A1, which is hexane. The base peak of the chromatogram is found at MZ equals 57, which is butane cation. 43 and 29 are both abundant as well. They're propylene and ethylene cations respectively, being that the 43 is the propylene and the 29 is the ethylene. The 86 peak is the hexane cation, and this is the cause of hexane molecules that did not fragment. And the one on the far right, we have image A is the last peak of the chromatograms spectrum. The enhanced version shows the different properties of the peak. Image B is a close match to A1, which is toluene. The base peak of this chromatogram is the MZ equals 91, which is the tryptophan cation formed from rearrangement to become stable, while the 92 MZ is the M+1 of the base peak of the graph. The minor peaks are different fragments of the toluene molecule. However, the largest of these fragments is the MZ equals 65, which is loss of neutral acetylene from the tryptophan ion. The next test we ran was high performance liquid chromatography, or HPLC procedure. First, we collected the samples of dirt. This test was not actually ran by us because of other issues, so I had to look up procedures to how this would be run. So this is the one I found from the paper and that I quoted below. So first, what was done is you would collect the sample of dirt, add precipitate reagent such as ethanol. This would then mix up the dirt and the samples. You would then centrifuge and remove the pellet, because you don't want the pellet, because the pellet consists of all the hard, still solid materials, and that can't run through the column or else it would ruin the column. So then you add the supernatant to the HPLC, which you then inject. The isocratic separation via HPLC happened at 30 degrees Celsius using the reversed phase column. An example of the column that was injected into is one on the right. That's not a column that was used, it's just an example of one. And then because a lot of those pharmaceutical properties were detectable at a UV light, they were recorded at 325 nanometers. So the results that would have been detected, which is the one on the right, is retinol right there. That was the one manufactured product that was inside my can. This was given by Dr. Sodoma and was then told to figure out how would we get this. So this graph is not one that was made by us. It was taken by the paper, which I then cited on below. So this chromatogram does show the presence of retinol. This demonstrates what the peak, if this was done, it would demonstrate the peak, that what would it look like, as well as how it would be detected. So this is very important for this test, for this analysis, because it shows if this was done properly, what I would find. So in conclusion, what has happened, the organic contaminants that were found was hexane, dichloromethane, and toluene. And the manufactured products that was found was vitamin A, retinol. Now the analysis that was got from this conclusion was that all components were detected. No other components were found in the sample. So that means that these were all what was found in the soil could not have caused the illnesses for those people. So other tests would be ran in other environments, such as contacting the people, trying to figure that out. But what this experiment does show, it allows further understanding of chemical detection, such as this could also be seen, such as in a crime scene. If an unknown liquid is at the scene, this could then be sent to a scientist, and they can then run these tests that were explained to try to determine what that would be. Thank you for listening to my talk, and have a wonderful day.